coordinator, for having invited me to deliver a talk in the title Deep Neural Network. So my presentation outline will be like this. Because I heard that the audiences, that is the participant of this 5 days FDP, are from different backgrounds. So my lecture today is very little. That means very light in nature. And my presentation outline is something like this. I will give some prerequisite information, and I will enter into a topic called biological neuron, then with artificial neuron, then entered into artificial neural network. With this background information, I will proceed into the today's topic, that is a deep neural network and its application, and the types of deep neural network. And finally, I will be giving you a demo of how this neural network model can be developed using MATLAB software. So the prerequisites are, I want you to understand few terminologies so that it is very easy for me to proceed further. So first of all, what is a deep neural network? So it is a special form of artificial neural network. What is artificial neural network? It is a network of neurons connected to create intelligence in an artificial way. Then what is neuron? So it is a small functional unit of human brain where intelligence are created in a natural way. How many number of neurons are there in human brain? So it is counted up to approximately 10 to the power 11 number of neurons, and they are tightly interconnected with one another like a mesh network, and are working in a parallel fashion in order to produce intelligence in a natural way. I hope the participant, you understand what we are going to deal in this 1 hour session. We are going to deal with a kind of algorithm called artificial neural network, which is the latest development in it, that is called deep neural network. So in general, what is artificial neural network is? It is the way of creating intelligence in an artificial way. That is, it is one kind of algorithm whose objective is to create artificial intelligence. And where this artificial neural network topic comes from? This topic is nothing but the inspiration of the working functionality of human brain. Because in the human brain only, human is building intelligence in a natural way. So as far as the intelligence that is to be created in an artificial way, we need to study the functionality of the human brain neuron. So then only it is possible for us to create an artificial version of the neuron. Once you created an artificial version, then you can easily form a network of each individual neurons. Once a network is formed, then you have to define function for each neuron so that they collectively work together to create intelligence in an artificial way. So one such special form of artificial neural network that is widely used, and most of the hottest topic of the buzzword in the data analytic industry is deep neural network. That's what the focus of our today's presentation. So let me discuss few things about the structure as well as function of a biological neuron. So if you look at the microscopic view of a biological neuron, you can find some important parts in it. One is soma. Another one is soma. One is soma. This, and one is a small thin fiber like structure, that is dendrites, and a long pipe like organ, that is axon. And where dendrites are connected with one another, you can find a small sponge like architecture, that is called synapse. So these are the 4 major parts in the microscopic structure of a neuron. So this is one neuron. Actually, this is one neuron. This is one neuron. This is one neuron. and this is another neuron. Likewise, you can find n 10 to the power 11 number of neurons in the brain. So for understanding, this is a microscopic view of two neurons. So how this neuron is functioning? See, these neurons are directly involved in the sensory kind of information associated with the human body. In case if you see some object, if you hear some words, or if you listen to some words, or if you are writing something, or if somebody else are touching you, or what if you are eating something, so those are all the organs associated with senses: tongue, your eye, your ear, skin. So these are all the organs associated with sense. And once the sense is uh, felt by these organ, the sense is carried out into the human body as an electrochemical signal, and that electrochemical signal is accepted by these dendrites. This dendrite accepts this electrochemical signal, and all the electrochemical signals, see, the electrochemical signals are coming from this one, this side, this side, this side. See, this side, this side, many dendrites are there. They get coming into a particular neuron from various direction. And what is happening is, at this juncture, see, at this juncture it gets accumulated. At this juncture it gets accumulated, and that accumulated information is carried out by the axon. This is axon. This pipe like organ is axon, and the axon once again carries the information, collect the information, and filled the information inside the soma. So the soma is the one which is treated as a cell body, or the core part, nucleus, which is capable of storing, accumulating the information. But one thing here you need to understand, that this soma is having only a definite capacity. Only it is having a definite capacity. That means it allows information to get accumulated over a particular limit only. Over that limit, it cannot accept. And what it can do is, it start eject the information, and the ejected information again will go back to the from the axon, enter into the dendrites, and get into the neighboring soma. That means neighboring neuron. So the informations are getting filled into the soma. Once it get filled up, if you cross its limit, it get ejected and getting into the neighboring neuron. Likewise, the information is getting passed over the neuron, and what is done at the end is, the information is getting processed. The sensory kind of information is getting processed, and the trivial knowledge about that sensory information is getting stored in the synapse. Through synapse only, we could recollect the object that we seen is a animal. The word that we hear is a good morning. The taste we feel is a sweet. Somebody else is beating me or kicking me like that. So these are all the collective working of the biological neuron to make one to feel about a particular sense. So the similar activity is inspired by the artificial neuron. Oh, so what is yes, artificial version. So this is the artificial version of the biological neuron. So it should contain some set of input units, and that input units are called by the name dendrites. And it should have a cell body, and the cell body is treated as a soma. And the soma is going to do two activity. One is accepting all the information, that is nothing but summation of all the input information. And another one is verifying the information whether it reaches the threshold or not, that is a limit or not. If it reaches the limit, then it will start eject the information. The ejected information will pass through the axon. So this is the way in which one can simulate the artificial version of the neuron based on the functionality of the biological neuron. So this is the mathematical model of the artificial neuron. So what it has, it contains some set of input vector, which is treated in the form of x0, x1, etc. up to xn. And for each input vector, there attached a weight vector. This weight vector is treated as the synapse in the biological version. So for each input vector, there associated a corresponding weight vector. And what is carried out here? So what is carried out here? Here, what is carried out? Some kind of accumulation of information. That accumulation of information is mathematically notated in the form of weighted sum. So over the weighted sum, what is applied? Some kind of limit activation function is applied in order to produce the output. So this is the mathematical model of this neural network, that is artificial neuron. So what are the calculations involved in this artificial neuron is, first of all, net input is calculated, that is treated in the form yin, that is xi into wi, where y equal to 1 to n. If you take n equal to 5, what it there is x1 into w1 plus x2 into w2 plus x3 into w3. Likewise, it goes up to x5 into w5. So those calculation is performed here in this particular unit. So in this unit, so what is conducted? This formula is executed. This is the expansion of the formula. So this is the calculation carried out here in order to imitate the sensory information accumulated into the soma. So what is the capacity of soma? It is a very limited capacity. It cannot accumulate all the information. So what it will do? So it will start eject the information. When it will start eject the information? After application of the activation function. So once the activation function is applied over the yin, so yin is the accumulated information. So over the yin, if you apply any activation function, so what is produced? Output y is produced. So this is the mathematical model of imitating the biological operation of a natural neuron in order to build intelligence in an artificial way. So how one can define artificial neural network? So artificial neural network, see, if you look at this picture, so this every bubble, you don't think treat this square, but you just think about this every bubble. See, this every bubble is a neuron. That means it is an artificial neuron. So what are the function of this artificial neuron? Two function. What is the first function? Calculation of net input. And what is the second function? Application of activation function to produce the output. So these neuron are not an individual neuron. Instead, it is a network of neurons. So that's why we have many neurons and they are connected one another in a mesh-like form. So what is, how do you define this kind of architecture? This kind of architecture is defined in such a way that it looks like a parallel processing system or distributed processing system. So it is a parallel and distributed processing system consists of enormous number of processing unit called a neuron, whose objective is to calculate the net input and produce the outputs. That is the idea. So while calculating the net input and produce the output, so what is done is the weight information is getting updated based on the error produced by the model. So that is the idea of understanding the function of the artificial neural network. So with this prerequisite and the preliminary information about the artificial neural network, let me go into the today's topic, that is deep neural network. So before that, I want you to understand the difference between the term deep with respect to traditional artificial neural network. So with respect to the word deep neural network, the traditional artificial neural network is viewed as a, this is the traditional artificial neural network. This is viewed, or this is called by the name shallow neural network. Shallow neural network. So why? This word is just opposite to the deep. So if you want to understand the more about the deep neural network, it is better to understand what that shallow neural network is, or what is the convolutional neural network is about. So this is the structure of a conventional neural network or a shallow neural network. So the word shallow as well as the word deep are opposite to one another in terms of number of layers present in between the input layer and output layer. In case of the traditional neural network, the number of layers between the input and output are normally one, or it may go up to two or three, like that. But when you take the case of a deep neural network, the number of layers between the input and output layer are enormous. That is, it is very depth in nature. Also, each layer that is present in between the input and output layer, that is hidden layer, is intended to perform different operations. Say for example, this particular hidden layer is interested to identify edges. This particular hidden layer is interested to identify a combination of edges. This layer is interested to identify futures. That is, when an image is given and our objective is to identify whose image is this, then one can go for using a deep neural network, and this deep neural network is having a enormous number of neurons, and that are arranged in many number of layers which are tightly connected with one another, and each layer is intended to do a specific task like this. So finally what we got is the desired output. But that situation is not here in the shallow neural network. So participants, I hope you understand the idea. So deep neural network is a neural network which is structured in a way of having more number of layers between the input and output, provided each layer is defined by a separate function. But that is not the case with the shallow neural network. That's why in modern application, the traditional neural networks are failing to produce expected output, whereas this deep neural network gains momentum and it is widely used for many applications. So the one of the most important tasks carried out by the deep neural network is a pattern recognition. So what is pattern recognition? So if you give an image, it may be any animal or any plant or any human being or anything else, even a satellite image or anything else. If you give an image, the objective of the pattern recognition task is to say what type of image it is. See, here the input given is cat image. Maybe it is a small cat, it may be a kitten or a puppy. But the objective is to give any one of the output, not all the output, any one of the output it has to say. When you apply a shallow neural network model for this kind of task, so what you can do is you have to do two different tasks. One task is separately and exclusively called feature extraction, and followed by the application of shallow neural network for identification of the exact image, what the image is. But when the case of if you want to apply deep neural network, so what its speciality with this neural network is this feature extraction task is embedded into the classification task. So you no need to go for understanding or analyzing some kind of feature extraction algorithm separately and some kind of classification algorithm separately. Instead, both the feature extraction as well as the classification task are available in the single model itself. So the single model will take care of the entire task of identification of what the given input image is all about. So that is the major difference with respect to function in terms of shallow neural network and deep neural network. In the previous slide, I have given the difference between the shallow neural network and deep neural network with it, in terms of structure, and here with respect to a function that is a task, a pattern recognition, how it is differentiated with one another. So the wonderful application by this deep neural network is face recognition. See how many layers are there in order to identify a human face. So if you give it a set of images, it has a set of layers in the form of input layer. It has a set of layers in the form of hidden layer. See, in the hidden layer, in the input layer itself, how many layers you have. In the hidden layer, how many layers you have. So all these layers have different functionalities. and these functionalities are collectively work together to produce the final output. This is what the simple application one can understand the architecture as well as the functionality of the deep neural network. So one popular category of a neural network in the deep learning neural network is convolutional neural network. So this convolutional neural network is also having many layers with respect to the idea of a deep learning, but the layers are having different names. So what are those layers? Once an image is given to this particular neural network model, the layers are convolutional layer, pooling layer, and fully connected layer, and finally output layer. There are 4 different kinds of layers. But what is actually is there is this convolution layer and the pooling layer alternatively present together in this architecture, and it has any number of layers. That is, you can have n number of convolution layers and m number of pooling layers. So say for example, if you have 5 convolution layers and you can have 10 pooling layers. If you have 10 pooling layers and you may have 15 convolution layers, like that you can have. But these layers should be alternatively present in the convolutional neural network model. And the final few layers before the output layer are fully connected layers, and finally you have output layer. See how what is the function here is, see, once the input image is given, our objective is to identify what the animal present in the input image, whether the image contains a dog or cat or deer or lion. So that is the objective. So when an image is given, our objective is to identify which kind of image it is. For that, this particular architecture will have many layers, and each layer is doing some operation. The pooling convolution layer is doing an operation called convolution operation. The pooling layer is doing an operation called pooling, and the fully connected layer is doing an operation called softmax, and finally the output layer is responsible for producing the output. So once the input image is given, the convolutional layer will do the task of future mapping, that is reduced form of input image. Same way, the pooling is also doing the reduced form of futures. So these 2 layers, that is the convolution layer and the pooling layer, will do the task of dimensionality reduction, that is future extraction. Then these 2 layers, that is fully connected layer and output layer, are responsible for classification. So as I said in the earlier slide, so future extraction as well as classification are embedded into the single neural network model. And this neural network model is a kind of deep learning neural network model and is called by the name convolutional neural network model. And what are the operations of this neural network model? Convolution, nonlinearity, pooling, or otherwise called subsampling, and classification. These are all the 4 major operation of this convolutional neural network model. Let me give idea about each and every operation. See, what is the input to this particular neural network model? It is always an image. So most of the image processing tasks that is very complex in nature and that are very unstructured in nature and that are very real time in nature, if you face such kind of problems, then one can automatically go for using the convolutional neural network model. So in this convolutional neural network model, when an image is read first, so first the input image is given. When an image is read, the first operation what you have to do with the input image is convolutional operation. So this is the sample scenario of how the convolutional operation is carried out. See, imagine the image is read as a matrix. For example, if the image is read as a 5x5 matrix, then what you need to do is you have to choose a kernel. So the kernel size should be a minimum size when compared with the image. And what is the convolution operation? It is simply a mathematical operation that conforms to a multiplication operation. But how the multiplication is carried out? See, assume this kernel in the form of 3x3 matrix whose values are 1 1 0 2 1 1, like this. So when you are going to do a convolution operation, what you can do is you can place this matrix over this matrix, and you have to scan this matrix over the entire image matrix from the starting column to ending column. So now I am placing the matrix over this first 3x3 elements of the given 5x5 matrix. So now I have to produce the output, yeah, 3x3 matrix. Now, in order to fill this first location, I have to place the matrix in this in this position. So how this output 13 is arrived? This 1 is multiplied with 1 plus 0 is multiplied with 1 plus 2 is multiplied with 0. That is here. Right? So then what is done? The 0 is multiplied with the 2, 1 is multiplied, 2 is multiplied with the 1, and 1 is multiplied with 1 here. So 7 is multiplied with the 1, 0 is 0, 0 that is here. So upon finding the total value of this particular products and the product of sum, I would come to a value 13. So likewise, I have to fill this first box. Likewise, I have to fill all the boxes by scanning the matrix from here at the first stage, and then in the second stage I have to place the matrix here, and in the third case I have to fill the matrix here, and in the fourth case I have to place the matrix here. So finally it will go here. So that is the final position that is shown here. So this is the value of the final placing of the kernel over the image matrix. So this is the operation that is performing the task of convolution. After convolution, so what is done is a ReLU operation. So ReLU is a kind of activation function, rectified linear unit. So it is a kind of activation function whose objective is to produce a 0 value in the place of a negative pixel. See, imagine this is the matrix. See, this is the matrix of given image produced from the convolution operation. Then this image is fed into the ReLU operation. So once the ReLU operation is fed with the help of a transfer function that is defined like this, so it will check the pixel value wherever the negative value is there. Wherever the negative value is there, accordingly the negative value is filtered, and in that place what is placed is 0 is placed. So that is the operation of ReLU. So what is the objective in the previous operation as well as this operation is, see, the original 5x5 matrix input matrix is converted into a small 3x3 matrix. And in the second operation ReLU, wherever you have a negative pixel, it means that it doesn't carry enough information for the image to be processed, so that the negative information is replaced with 0. So this is the activity performed in these two operations. Next, pooling operation. Pooling is a sampling operation. See, the 3x3 kernel matrix size image that is produced out of convolution operation is again reduced to a 2x2 matrix like this. So this kind of operation, how it has to be performed is, this given image is divided into 4 quadrants. See here, this is first quadrant, this is a first quadrant, and this is a second quadrant, and this is quadrant. So with respect to different colors, it is the quadrants are clearly indicated. And what you have to do is, you have to do a max operation. You have to do a max. There are many pooling operations are available, average, max, like that. So you have to do a max operation. So what is the duty of max operation? You have to count the pixel values. This is 1, and this is 2, and this is 6, and this is 4. So out of this 4 value, which is the maximum value? 6. So I have to print 6 here. Likewise, I have to scan the next 4 elements, next 4 elements, and I have to finally find out the matrix. See, image which is a 5x5 is reduced to a image of size 3x3. Then it is reduced to a image of 2x2 like this. So this kind of this is called a future mapping task. So this kind of future mapping task is continuously applied. Then what you can do is, final image is fed into the neural fully connected layer. So that is the idea. So the final layer are doing the task of classification. The first two layers, convolution and pooling, are doing the task of feature extraction. And this two layer fully connected and output layer are going to do the task of classification. So what is the purpose of this classification is in order to identify what exactly the given image is. So what this kind of layer is, this kind of layer is exactly equivalent to the traditional neural network model, that is the shallow neural network model. And this task involves the application of some function called a softmax function, which is used to understand the different probabilistic values of the given image. That is, upon carrying out these kind of operation, the input image is set as dog with the 0.1 as probability, cat as a 0.4 as the probability, deer as the 0.94 as the probability, lion as the 0.2 probability. So out of these four probabilistic value, which is having the most higher probability value, deer. So that value is taken and it is produced as the output. So that means the given image is a deer image. With respect to the various operation, ultimately we came to a conclusion of the given image with the almost maximum probability value, that is a deer in this particular case. So this is the preliminary CNN model, what I have told just now. But there are many CNN models are available. That model that I just explained to you is a LeNet model. There are other CNN models are available called AlexNet, ZFNet, GoogleNet, VGGNet, ResNet, DenseNet. So you can use any one of this ready-madely available CNN model, and you can load your image. Say for example, Vikram lander is a problem. You can get many satellite images, and for weather forecasting you can get as many images, and for identification of whether water is there in moon or any planets, you can get many satellite images, not only with respect to satellite images but also with respect to tagging, image tagging in social media. So those kind of stuff are very popularly using these kind of neural network model that are ready-madely available, and you can plug into your image, analyze your image, and predict the
Sir? Ganesh Kumar, sir? Participants, please hold on. I think there is a technical issue with the speaker. We'll try to solve it out. Sir, Ganesh Kumar, sir? Sir? Is it audible, sir?
Yes, ma'am. audible. Screen share enable பண்ணி விடுறீங்களா?
Sir Ganesh Kumar, sir.
Hello.
Sir, audible, sir.
Yes, ma'am. Screen sharing கொஞ்சம் enable பண்ணி விட்டீங்கன்னா, yes, it is enabled.
Sir.
Hello.
கேக்குது sir. Screen தெரியுது sir.
Okay, ma'am. Okay, ma'am. Sorry, ma'am. இடையில கொஞ்சம் network disconnect.
Sir, கொஞ்சம் voice கம்மியா இருக்கு sir.
Okay, okay, okay. Okay, ma'am. கொஞ்சம் sound increase பண்ணிக்கிறேன். So this is the new neural network model, which is having a kind of connection called a feedback connection. So with the presence of feedback connection, what we can achieve is we can achieve some different kind of state. That is some kind of past state to produce the present state. So every time the present state information is fed back, so that the feedback information is treated as a fast state information, and that fast state information is again fed into the output layer to produce the output. So for this kind of feedback connection, what we can have is a kind of short-term memory we have. So this short-term memory, what it will do is it will hold the memory for a particular amount of time with respect to particular value, which is fed back to the layer. Again, this information is retained. Again, what it does, that another stage of information is getting feedback. So likewise, once in one side, the information is feeding for in the forward direction, but in that particular point, the information is feeding back. So this kind of neural network is working with respect to time. So the normal back propagation algorithm with respect to time, that is BPTT, can be widely used as a training algorithm for this kind of model. So this is the general RNN model, and how you can make this model as what is that deep model is, you can add more number of nodes in between the layers. So how we can add hidden states between the layers? See, this is a kind of neural network with respect to input layer here. See, X is the layer which is treated as input layer, Y is the layer which is treated as output layer, and H is the hidden layer. So here, how we can increase the hidden layer? That is how you can make the this simple RNN into a deep RNN. You can increase the hidden layer over the one another of H. So one here, another one here, another one here, another one here. Likewise, you can keep on increasing the model with respect to increasing the simple RNN into a deep RNN model. Another model, what you can do is, so you can go for increasing the hidden layer in this way. Here you can increase. Here you can increase in the number of hidden states. And the third one is, here you can increase the hidden states. And the fourth one is, you can increase inside this model. So this is the four way. The first way is making the hidden state one over the other. The second is making the hidden node between input and output layer. The third one is increasing the hidden layer within the hidden layer, and the fourth one is increasing the hidden layer between input and output layer, between the hidden and output layer. So these are the four ways you can make the hidden layer to get increased, so that the simple RNN model will become a deep RNN model. So there are different flavors of RNN model is available, and each model is responsible for a kind of task. The first model we see here is a model, this one, that is, it is having a connection one to many connection. See, one to many connection, and this one to many connection. See, this is the simple model without RNN. This is without recurrent connection, so this is not an RNN. But let me take this one to many connection RNN. That means one input is one, and output is many. So that is the idea here. So one to many means one input and many output. So in that case, one to many. So what is the application? Image captioning. See, when an image is given to you, you need to caption the image. The image containing a natural scenario, which contains mountains, tree, some animal, or some some kind of bushes is there means you need to identify what are those. Say for example, if you have some satellite images, you need to identify whether this portion belongs to a mountain portion, this portion belongs to a forest portion, this portion belongs to a building. Likewise, if you want to analyze, so those kind of stuff, if you want to analyze with respect to ornament model, then what kind of connection you can go is you can go for one input and many output models. So that is sequence output. The output is sequence in nature. So what is you can do is you can do a task called image captioning. And with respect to social network, you have one more task called sentiment analysis. So in this kind of sentiment analysis, say for example, putting a review on the movie and saying your opinion about a particular incident, and you have expressing with the emojis with respect to smileys. So whether that is positive or negative, those are the stuff dealing with the sentiment analysis, for which the number of inputs are many, but the output is only one. So many can post their review, but the output is only one, whether it is good or bad, whether it is positive or negative. So those kind of connection, if you connect your RNN model in this fashion, that is many input node and one output node, then what kind of application you can go for is you can go for a sentiment analysis application. And then another fourth one, sequence input and sequence output. See, this is many input and many nodes. So here the input is sequence input. Whereas here also you have many to many, but what is the case here? It is synchronized sequence input. That means here you have used a Google Translator. So in Google Translator, if you type something, based on the word you type, the corresponding translation is happened in with respect to the target language. So those kind of language translation uses this kind of model. But for this case, you have using a video. If you are giving a video and wherever some liquor drinking scene or wherever some adult content is there, if you want to cut that content, or if you want to give some saturated or warning information over the content, or if you want to classify the videos with respect to the frames, then you can go for this kind of many to many model, provided here this many to many model consists of synchronized sequence input. But when you take this many to many model, this is the kind of application called language translation, where your Google Translator is working. So likewise, you can find many apps which gives language translation. So that kind of stuff you have to use the sequence input and the sequence output model, that is many to many model. So this is the many varieties of application one can go for using the RNN model. So with respect to RNN, with respect to different kind of connections, you can find n number of applications. All those applications are currently needed applications that are widely expected applications from the computer science and other kind of stuff students. And there is a problem with this RNN model. What is the problem is short-term memory, vanishing gradient, and exploding gradient. So what is short-term memory? See, I already told that there is a small amount of memory is there. Hence only it retains the previous information with respect to feedback connection. But what is the actually carried out here is when you go for very high-end application like streaming application or any real-time application, this short-term memory won't be a sufficient one. What you need is we need to have some long-term memory. So that is the problem. And another problem is vanishing gradient. So what is vanishing gradient is? Gradient is nothing but synapse. What that I explained with respect to a human brain, synapse or weight. So that is the other gradient is the another name for weight or a synapse. So what is the duty of making the neural network model is updating the weight during the course of learning the model. So while updating the weight, what you can find is you can find two different things. One is the weight can be updated in the negative side, or the weight can be updated in the positive side. If the weights are getting updated in the negative side, at one point of time, the weight can be near to zero. That means it is going almost vanish. If you keep on increasing the weight in the positive side, at one point of time, it goes up to infinity. That is, you can't imagine the weight value and you cannot bear the image value. So those two situations make the neural network model as an unstable model. So the model won't be a good for some kind of applications that we have discussed earlier, like image capturing, sentiment analysis, those kind of applications. So for which, what you can do is you can go for some new advanced model in the deep RNN model. So those models are called by the name long short-term memory deep neural network, gated recurrent unit deep neural network model. So this is the idea in this model. Here, some kind of mathematical functions and some kind of mathematical operations have been inbuilt into the neuron unit with respect to the operation that I told in the earlier, accumulation and activation. In addition to those functions, here some kind of additional operation have been carried out in order to produce long-term memory, as well as in order to stop the vanishing and exploring gradient. So this is the two widely used latest deep neural network model with respect to RNN, long short-term LSTM and GRU. So these kind of stuff are popularly used in again speech recognition, text generation, and video caption. I think with this, I will close the theory part and let me go into yeah, kind of demo part. I will stop the screen now and I will share a new screen, my MATLAB screen. I hope the MATLAB screen is visible now. Anyone, please? Is the MATLAB screen visible? Hello? So can you, yes. Yes, okay. So yes, thank you. So here I will give you a demo. Before giving you a demo about this model, I will give one URL so that you can find where you can get these kind of stuff. I have copied this URL and pasted you in the everyone. So I am pasting you a URL here. You can use this URL to for further exploring the idea of the model. I hope you all, everyone got this URL, right? So this URL, you can use it for further understanding and development. I will explain this URL first. Let me share this screen for a while. Stop screen. Share screen. So is the web page is visible? Can I get any response? Is the web page is visible? Yes. Okay. Thank you. So this web page is official web page from the MATLAB developer community. That is MathWorks website. And this MathWorks website will give you the idea how to develop the model. So this first demo is the one which is going to give a demo for CNN, convolutional neural network model. As I said, convolutional neural network model is widely used for only image processing task, whereas RNN model is used for speech recognition, language translation, and video classification. For these three kind of input, RNN is suitable, and for image, CNN is suitable. So here, what is the objective is some kind of handwritten characters is given, like 1, 2, 3, 4, 9, like that. Some kind of handwritten character is given, and your objective is to what is that? Your objective is to classify whether the handwritten character belongs to 1 or the handwritten character belongs to 5 or 9, something else. So that is the idea. So in this MathWorks help demo documentation page, so every detail is given very neatly. So with respect to a step-by-step manner. So how to proceed? First, you have to load the data. So this is the code for loading the data, as well as defining the image, understanding the input data, and here how to I identify how many number of data are available and how to read the data and how to define the structure, how to train and validate the structure. So every detail it has been given in the page. And finally, how the output will be produced and how do you visualize the output and how do you infer the output, and finally how much accuracy you have obtained. So everything you can produce it here. So after reading this page, you can test it on your own with respect to the MATLAB software you have. See, remember, the MATLAB software you need for this software for this problem is MATLAB version 2019. So you can understand the demo. After understanding the code that is given here, you can replace this image with your own image. Say, for example, instead of 8, you can have an image of face of one person, face of another person, face of another person, like that. You can have n number of persons image, and you can use it for facial recognition. So instead of identifying the handwritten digits, you can identify the face also. Likewise, you can replace this program for any purpose that, or any research problem that you have. So let me stop the screen and go back to the MATLAB. So is my MATLAB screen visible? May I get some response?
Yes, sir, it is visible, sir.
Okay. So since I have already created the code for this problem, I will open the code directly. CNN model. So this is the code. So this code is simply just a copy paste from the MathWorks web page I have shown to you. So those information is there. This is the one. So wherever that gray color box is there, those information is copied and pasted in the MATLAB environment. So that is the idea. So I will going to execute the program by clicking the run button. You will see the output. So it will take them some time. Yeah, the output has come. So first the input image is coming, and every iteration how the image is processed and how the values are produced. See, one window is giving the accuracy percentage. See, another window which is giving the loss, that is error, and other parameters associated with the model are displayed here. So you can use this for further analysis or reporting your result. So that's it. So this is the way you can see the output. So this is the sample images. So how many images are there is totally 10,000 images are there. See, with the handwritten character 0, 1,000 image. Handwritten character 1, 1,000 image. Likewise for handwritten character 9. So 0 to 9, that is a 10 image, 10 different images. For each images, 1,000 images are available. So total 10,000 images. Out of the 10,000 images, how many images have been taken is, see, if you look at it here, 750 images have been taken for training, and 250 images have been taken for testing. So from the 250 images, how much accuracy has been produced by the model, that is the final output one can expect for any ANN based research problem. So that is the idea. And another demo that I wish to give it to you is, I have already given you in the chat one more URL I have given, that is with respect to RNN. With respect to RNN, so here the RNN model. So RNN model always used with respect to a kind of data called sequence data or a series data. That is a data with respect to time. So if you have any data, and if that data changes with respect to time, time means it may be a day, or it may be a month, or it may be a week, like that. With respect to something else, if it is changing or if it is keep on changing, means then that kind of data is used by the RNN model. So what kind of RNN model here it is used? Long short-term memory neural network. So this sample page, that is a demo page, when the MathWork website is giving you the demo with respect to chickenpox dataset. Actually, what is the dataset is about is in the x-axis month is there. So 0th month, first month, second month, up to 500 months data. So the data is collected for about 500 months. And how many cases reported? Reported with respect to patients affected by chickenpox. So the same scenario you can think about the present situation, COVID. So with respect to the beginning day of the disease affected person, until now you can keep on collecting the number of data. That means number of cases, positive cases, and you can store the data, and you can use this model to build the architecture to predict the future patients or future possible number of cases that may be expected from the ANN model. So this is the stuff here. So what is the objective of this demo is it is going to load the chickenpox data set, and with respect to time frame, the model is developed, and it is going to predict, and it is going to predict out of for 500 months. So for up to 400 months, the data will be treated as the data for training, and beyond that, we need to test whether the model has been correctly predicted or not from the month 400 to 500 months. And this is the actual data, and we need to get the predicted data here. See, this is the predicted data, and you want to verify whether the actual data and the predicted data seems to be same or not, or if it has deviated, so how much amount of value it has deviated, and you need to update in order to produce or in order to make the observed as well as the predicted go to be in the same line. So this is what the demo we are going to see here. Let me execute this program. So again, I copied the code in the demo page only. So I'm going to execute. So get the, so this is the case. The screen is visible.
Yes, sir.
Okay, thank you. So the with respect to so many iterations, the root mean square error is calculated, and the corresponding loss is calculated. So maximum 250 iteration is the made. So the value that is calculated under each generation is recorded, and it is plotted for the chickenpox data set. So if you have, I think if you keep on watching the news daily, you could get the data of COVID with respect to country, with respect to our country, with respect to district, and with respect to state. So if you go have all these kind of stuff, then you can also build a model using these kind of neural network algorithms. You can predict the future cases, whether it will be positively correlated or it will be negatively correlated, like that kind of analysis you can do. So this is the one that is the initial case. Initially, the model doesn't fit well, and you have the error value more. See the error value more. So upon keep on updating, somehow the observed line, the predicted line are one and the same, and the root mean square error is also reasonably reduced from the original value of 182. So likewise, you will analyze, and you will suggest, and you will recommend this kind of model for a kind of time series analysis. So this is for a normal time series analysis. And if you go through this MathWorks website, you can find enormous number of other applications. Like these are the links here available. I have given you a demo about called time series data, that is chickenpox data, and you can go through these pages and you can understand many other models like video classification and fault detection, and many models you can find. See, these are all the examples. You can use this page well, and if you study those code, and if you are used to implement this code, you can very well implement that code with the help of the MATLAB software, provided the MATLAB should be the latest version. After you implemented it, after you have thoroughly verified it, you can change the data, and you can use your own data in that place of the automated data, and you can verify the same. So I think with this, I have showed you the demo, and I have achieved the publish session. If you have any queries, ma'am, shall I stop here and I can open
Yes,
for
sir. Yes,
query?
sir. Yes, sir.
Okay.
Yes, sir.
So if you have any query, you can ask. Actually, this is a very big topic, but for 1 hour, I want to give this kind of topic as an eye opener, and I expect you to explore further into this. So if you have
Okay,
any
sir.
query, I may be in a position to clarify your query.
Uh, yes.
Dr. Neelam Tiwari, some have raised the hands. Some participants are raising their hands.
Yes, sir. Participants, if you have any queries, you can post it in the chat window. And now I have enabled chat for everyone. Sir, they're asking about open source, and there are so many questions are posted, sir. Can you see it, or shall I read it out, sir?
Please keep on coming it.
Yeah, it's keeping on scrolling. As I have enabled the chat, it's keeping on going. I'm not able to
One
figure it out.
question is, Dr. KP Sivagami, are the data sets available freely? Yes, ma'am. The data sets are available freely. There are many data set portal are available. Even IEEE data port and Derry data set competition portal are available. You can use those kind of portal for utilizing your research and other things. Many portals are available. Only thing you have to Google it, they can get it. If you want to have your own data, you can also collect the data. Any thanks message and do you find any question, ma'am? Because I find
Yes, sir. So many, it's getting scrolling off. There are so many questions. Are
CNN
there?
is only feed forward or DNN is circle. Yeah, yes. CNN is
Rajalakshmi.
Rajalakshmi Swaminathan. Yes, CNN is simply a feed forward neural network. But what is the thing is, it is having n number of layers. The convolution layers are there, and absolutely that not DNN, RNN. RNN is recurrent. It is having some feedback connection. So that is the difference between CNN and RNN. And of course, the intermediate layer with respect to CNN is convolution pooling, like that kind of layers are there. But in respect to RNN, those kind of layers are not there. It has many hidden layers, and each layer is intended to be a same task. But what is the thing is, the hidden state is represented with respect to time. Hidden layer value with respect to time t equal to 0 is utilized for the hidden layer execution with respect to time t equal to 1. And the hidden layer with the value with respect to time t equal to 1 is utilized for the hidden layer value with respect to time t equal to 2. Likewise, it goes on. So some kind of feedback connection is there. That case is not with the CNN. That is the difference.
Sir, one question. Shyamla Devi.
This software is open source. MATLAB is not an open source software, ma'am. It is pirate Selva. Software is not an open source. It is purchased version only. But you can do the same with respect to R software, or with respect to Python also you can do the same thing. Only thing, the library files and the editor is differing, but the logic is same. Logic and idea, everything is same. You can try it with other open source software like R and Python also. Yes, ma'am. You please say, ma'am. You have one more question here, like that you asked.
Yes, sir. Actually, I was having a question, but so there are so many questions and it went up.
Okay. You can ask, ma'am.
Okay. Sir, one question.
Yes,
from YouTube link, sir, from live YouTube.
Okay.
Dilip Kumar, how can we define kernel size value, SAN value?
Yes, sir, the kernel value size is defined based on the trial and error approach, sir. So if you have image, see in this example with respect to the slide presentation, image of size 5 cross 5 is taken, and so that for explanatory purpose a kernel size of 3 cross 3 is taken. But if you go to the general case, there are some standard CNN models are available. There have been already defined kernel sizes are available. You can just use those kernel sizes with respect to the image size that you are having. So with respect to the image size, you can use the corresponding kernel size. So if you go for LeNet, some kind of kernel size is used. If you go for VGGNet, some kind of kernel size is used. So likewise, with respect to model, the kernel size is varying, and it is also up to you to decide the kernel size based on the accuracy you are going to have. If you are getting very less accuracy, that means you need to increase the kernel size, because you need more and more features to study. If you reduce the kernel size very small, then the number of features is also getting reduced. Then it may lead to some loss of some information. If the information is lost, then the prediction won't be a good one. So that's the idea. Is there any other question, ma'am?
Sir, there are lots of questions, sir. There are lots of questions, and I think due to the time constraint, we can stop it. And
I think you can, if possible, you can send those questions to my mail so that I can reply.
yes, sir. Yes, sir. The chat
I am
window
ready to
is.
answer every question. So one question is, which one is better, MATLAB and Python? Ma'am, yeah, any software is the software that is used to verify your logic only. So it is not a comparison between MATLAB or Python. But if you want to carry your code in a portability platform, in a different platform, across a different platform, then Python and R only the best one. MATLAB won't be a code for supporting the portability. But nowadays, there are plugins are available. There are some library files are available to interconnect MATLAB with Python, and Python with R, and Python, MATLAB, R code with what is that? Big data analytics, Hadoop platform, like that stuff are available. So you can go for anything. Also, Delphi enough data sets available. Yes, ma'am. You can find data sets even the agricultural university is providing. I think I will give some papers in my area. We are working with a kind of groundnut leaf disease. The leaf affected by the leaf of groundnut plant affected by disease. We have collected roughly 7 to 8 diseases are available, and we have developed a CNN model to identify those. These images are available, and you can collect it by putting a proper MOU between the agricultural university or the persons who is providing the data. Or you can find some websites also with respect to different country data you can get. Ma'am, you design, ma'am, whether you will be taking the question to my email or what it is, or can we proceed further?
Yes, sir. Yes. Actually, what we thought is we'll be sharing the presentation, sir. That is your presentation to the participants, and I think you have mentioned your contact number and email ID also in that.
Yes, ma'am.
So it will be useful for them, sir. And tomorrow also we are going to have the session from you.
Okay,
so at that time also we can have some more discussion time, sir.
Okay, ma'am. Okay. Sure.
Thank you, sir. We'll have tomorrow Fussy. Am I correct, sir?
Yes, ma'am.
Fussy. Okay, sir.
So
thank you, sir.
Okay, ma'am. Thank you, ma'am. Thank you, participant. So I think they will share the slide. You can get the number, and or else you can note it here also. So my email and number. If you have any query, don't hesitate to mail me. You can send mail, or you can WhatsApp me. That number is my WhatsApp number. You can ask query if you have, or if you want any code with respect to things, or if you want to have any data that I am having, so you can go to my Google Scholars page, or any my Scopus or Orchid page. You can find my publication. If you are interested in extending my research, you can ask the data from me. I can provide you the data. No problem.
Okay, sir. Thank you, sir.
Okay, ma'am.
Thank you.
Thank you.
And this is the general instructions for the participants. We have posted the feedback link in the chat window. Today's feedback link. So please fill the feedback form for attendance, and tomorrow also we'll be getting the feedback link. And there are so many questions, and there are so many mails regarding the feedback link of our earlier days. As we have mentioned already, this feedback link will be available only for 1 hour or 2 hours, and it will be closed automatically. So it is not possible for us to open that feedback link, but it is no problem. You can fill it today's feedback, and tomorrow also you can fill the feedback and you can get the certificate. So those who have submitted the feedback form today can leave this meeting, and others, you can use this feedback form to submit your things. And one more thing, after the 5th day, we'll share the resource person's PPT, that is a 5 days PPT, to your registered email ID. And daily we'll not be sending the PPTs. After the 5th day, we'll be sending you the PPTs to your registered email ID. And recorded versions, it is not possible. It is not possible to share the recorded versions, and we'll see for that. Participants, we gave the feedback link of today, and you can submit it. And earlier feedback forms, the link has been closed and you'll not be able to fill the feedback form of your earlier days. Participants, Ganesh Kumar sir email ID and phone number is visible on the screen. It is shared, and you can keep a note of it. And if you have any questions further, you can contact sir about today's topic. And tomorrow also, Ganesh Kumar sir is going to take topic on FUSSY. Thank you, participants. Thank you.
Thank you, ma'am.
Thank you, sir. Thank you.
Thank you, ma'am.
We'll meet tomorrow, sir. Thank you.
Okay.
And this meeting will remain for yet another 10 minutes for the participants to fill their feedback.